Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley, and this is the presentation for Lesson 7-5B, Systems of Linear Equations in Three Variables. It's a short document, but it's kind of a long process, so let's get right to it. Today we're going to solve a system of linear equations in three variables. Now, we've talked about a couple of different methods of solving systems of linear equations. We've done substitution, we've done row reduction, Gaussian, which is also Gaussian elimination, and we've done graphing. Um, but if we're doing three variables by hand, we must use the elimination method. And so I've got an example of how we're going to do that. And so just to kind of go over the process that I'm going to use here, um, I'm going to label this equation right here, equation number 1, except I'm going to make it smaller. I'm going to label that equation number 1. I'm going to label this equation number 2. I'm going to label this equation number 3. All right. And so the first thing that I want to do is I want to reduce x's by combining two pairs of equations. All right. So the first thing I'm going to do is I'm going to take this first equation and I'm going to multiply equation number 1 by 2. So I'm going to go 2 times equation number 1, and then from that, what I'm going to do is I'm going to subtract equation number 2 from that. All right. And what that's going to do is that's going to cancel out the x's there. All right. So let's go ahead and rewrite that. So 2 times x is 2x. 2 times 3y is 6y. And then 2 times 4z is 8z. And then 2 times 19, 2 times 20 is 40. So we subtract, we get 38 there. All right. Now, for this, excuse me. And now I'm going to rewrite this second equation. So we're going to go 2x minus y plus 3z equals to 9. And we're going to subtract these. All right. So I'm going to subtract these out. And 2x minus 2x is going to give me 0. 6y minus negative y is going to give me 7y. And then 8z minus 3z is going to give me 5z. And then 38 minus 9 is going to give me 27. No, it's going to give me 29. Let's do a better job of subtracting. All right. This thing I am going to label equation number 4. It's equation number 4. All right. So I still need to combine two pairs of equations. And as long as I don't pick 1 and 2 again, I can choose any other bunch. So I could combine 2 and 3. I'm going to combine 1 and 3 because then I don't have to do any multiplications here. I'm just going to subtract 1 from 3. So I'm going to go equation number 1, and I'm going to subtract from that equation number 3. And so let's write that. I'm going to go x plus 3y plus 4z equals to 19. And then from that, we'll have x minus 2y plus z equals to 0. And remember, we are subtracting this. All right, so x minus x is 0. 3y minus negative 2z is like plus positive, so I have 5y. And then 4z minus z will be positive 3z. 19 minus 0 is 19. And that is going to be equation number, not 4 there, McCulley, equation number 5. All right, so now I want to combine equation 4 and 5 to eliminate y's. All right, so how am I going to do that? Well, unfortunately, the numbers are going to get kind of big here because I've got a 7 and a 5, and they're both prime numbers. So I'm going to go 5 times equation number 4, and then I am going to subtract that 7 times equation number 5. All right, so let's do that. All right, so 5 times equation number 4. So 5 times 7 is 35, y. And then 5 times 5 is 25z. And then 5 times 29, well, 5 times 30 would be 150. So if I subtract 5 from that, I'll get 145. That should work. And I'm going to pull up my graphing calculator while I'm doing that last calculation here. And then 7 times 5. So 7 times 5y is 35y. And then 7 times 3 is going to be 21z. And then 7 times 19. Well, 7 times 20 would be 140 minus 7 would be 1. Let's see here. 7 times 9. Let's just grab a calculator and do it. All right. Close. Grab a calculator. 7 times 19 is 133. Okay. All right. So again, I'm subtracting here. So subtract those. 35y minus 35y is 0. 25z minus 21z is going to be 4z. And then 145 minus 133 is going to be 12. And so now all I have to do is solve for z. And that'll give me z equals to 3. All right, so now we're going to plug z equals to 3 into equation 4 or 5 to solve for y. So let's see, which one will be easier here? This got smaller numbers. I don't know if it's going to be any easier, but so equation number 4, go 5y plus 3 times 3 equals to 19. All right, so 5y plus 9 equals to 19. Subtract 9 from both sides. I get y equals to, or 5y equals to 10, and then y equals to 2. Okay, so now plug plug y equals to 2 and z equals to 3 into 1, 2, or 3 to solve for x. And so I go all the way back up to the top here, and let's see what looks easiest. I'm actually going to choose this one. This one looks easiest. So x minus 2 times 2 plus 3 has to equal to 0. All right, so I've got x minus 4 plus 3 equals to 0. So x minus 1 equals to 0. X has to equal to 1. So now I know my final answer will be 1, 2, 3. And then we write this as an, oops, not and, just an, right, as an ordered triple. I think, is there 2 P's in triple? I don't know. Anyway, if I'm wrong, you can laugh at me. So That's all I got for today. So the Marvel fun fact of the day: in Black Widow 2020, Rachel Weisz plays Milena Vostokov, but this isn't her first genre film. She's also been in the comic book film Constantine in 2005, and she was also played with which was with Keanu Reeves, and she also played in 1999's The Mummy with Brendan Fraser. So a very storied career. That's all I got for today, folks. Have a good day. Bye.